A chemical doesn't lie about what it actually is, even when the paperwork does. I've worked hazardous materials response for the state for 20 years, the last 12 as an incident commander running scenes at rail derailments, highway spills, and industrial releases, and the one lesson that's kept every responder under my command alive across 2 decades is that you trust what your own trained senses are telling you about a release in front of you over what any placard, manifest, or dashboard says it's supposed to be, because paperwork gets things wrong considerably. More often than most people outside this trade ever realize. My name is Bridget Vance. My stepdaughter, Nadia, is the State Emergency Management Agency's Chief Innovation Officer, the woman who spent the last 2 years building and championing Response Sync, an incident command support platform that automatically calculates safe working distances, evacuation zones, and required protective equipment based on a hazardous rail car's shipping placard and manifest data, deployed to every incident commander's tablet across the state. This is a story about Nadia, about a system she genuinely believed had solved one of hazmat response's oldest problems, getting responders the right safety parameters fast enough to matter, and about a June evening at a rail derailment when Response Sync confidently calculated safe zones for the chemical listed on a tank car's placard, while the actual vapor cloud rising off that car told a considerably more dangerous story to anyone who'd spent 2 decades learning to read one directly. Response Sync came online across the state's hazmat response network 2 years ago, a platform built to instantly cross-reference a rail car's placard number and manifest data against a comprehensive chemical safety database, calculating recommended evacuation radius, required personal protective equipment level, and safe approach distances within seconds of an incident commander entering the car's identification number, replacing a process that had traditionally required responders to manually look up chemical safety data sheets under real-time pressure at an active scene. Nadia had pushed hard for the system from its earliest proposal, arguing, correctly, that the minutes lost manually researching an unfamiliar chemical's safety parameters at an active incident represented real, measurable risk to both the public and to responders themselves. Risk a fast, reliable automated lookup could meaningfully reduce. Response Sync pulls directly from the placard and manifest data every rail car is legally required to carry. Bridget, she told me, more than once, at a family dinner I'd hosted since she was 12 years old, it's not guessing at what's in that car, it's reading exactly what the shipper declared it to be. That's the same information you'd be looking up manually anyway, just delivered in seconds instead of minutes. I don't doubt the database itself is accurate for whatever chemical the placard actually says, Nadia. What I'm telling you is that placard and manifest data is only as reliable as whoever attached that placard to that car back at the shipping terminal, and placard mismatches happen in this industry more often than most people realize. Human error at a loading dock, a car getting relabeled incorrectly after a previous shipment, and I've personally worked 2 incidents in 20 years where the placard on the car didn't match what was actually inside it. I want to be fair to what Response Sync actually got right, because this isn't a story about a system built carelessly, or a stepdaughter who'd stopped caring about the responders working scenes across the state the moment she moved from field operations into a technology leadership role. Response Sync's rapid lookup had genuinely improved response times across dozens of incidents over 2 years, exactly the kind of careful, defensible engineering Nadia had built her career on after 8 years herself as a field hazmat technician before joining the agency's leadership team, and I never once doubted she believed in it completely, right down to personally reviewing every incident report the system generated. What the system didn't have, and what nobody building it had fully understood the danger of, was any way to verify that a placard and its underlying manifest data actually matched the chemical physically sitting inside a specific tank car, a documented, if uncommon, industry failure mode that meant Response Sync could calculate a confident, precise, entirely correct set of safety parameters for exactly the wrong chemical, with no mechanism built into the system to flag that mismatch unless a responder on scene noticed the physical reality diverging from what the screen was telling them. Nadia had come into my life when she was 12, not long after I married her father, and I remembered the particular careful patience it had taken both of us, over the years that followed, to build the kind of trust that let 2 people argue honestly about something as consequential as a safety system without either of us treating the disagreement as anything more than exactly what it was. I'd watched her grow from a kid trailing along on family visits to hazmat training exercises into someone who genuinely understood this work from the inside, and I think that shared history was part of why our disagreement over ResponseSync's blind spot never once felt, to either of us, like a fight about whether she belonged building the tools this agency now relied on. I need to explain the specific hazard this story turns on, because it's the actual center of everything that happened that June evening, and because it's exactly the kind of source data error a lookup system, built specifically to trust the placard it was given, was never designed to independently catch on its own. Placard and manifest mismatches, while uncommon, are a documented and recognized hazard within the rail hazmat industry, typically arising from a car being reloaded with a different chemical after a previous shipment without the exterior placard being properly swapped, a human procedural failure at the shipping origin rather than any flaw in a car's actual construction or a rail line's operation. I'd personally encountered exactly this scenario twice across 20 years, both times catching the mismatch through the same method, trusting the physical evidence of the release itself, vapor color, smell, reaction with surrounding materials, over what the paperwork said should be happening. A skill I'd developed specifically because a mentor early in my career had drilled into me that the placard tells you what someone believed was in that car, not necessarily what's actually in it. I'd raised this exact concern with Nadia nearly a year before this story's events, during ResponseSync's design review, describing both prior mismatch incidents from my own career in detail. ResponseSync's database is only as good as the placard data it receives, Bridget. I understand mismatches happen, but building an automated cross-check against the actual physical release would require sensor technology this system simply doesn't have access to at the incident command level. We're working with what the car's paperwork tells us, same as responders always have. I understand the technical limitation, Nadia. What I'm telling you is that ResponseSync's confident, fast, precise output is going to make responders considerably less likely to independently question the chemical identification the way we used to when the lookup itself took longer and felt more like an active judgment call rather than an instant, authoritative answer. I want a standing protocol requiring incident commanders to visually and sensorially cross-check the release against the system's identified chemical before committing to its recommended PPE level, built into training as a mandatory step, not just something responders are trusted to remember to do on their own. I'll add a cross-check reminder to the interface, but I can't slow down the core value of instant lookup by requiring a manual verification step that adds time back into exactly the process we built this system to speed up. I remember leaving that design review understanding exactly where Nadia was standing, even as I disagreed with the conclusion she'd reached from there. She'd spent 8 years in the field herself before she ever sat behind a technology leadership title, and I knew, better than almost anyone at the agency, how many genuinely dangerous minutes she'd personally lost early in her career manually paging through chemical safety references while a release kept spreading. Minutes of fast, confident lookup could meaningfully recover for responders who needed exactly that speed. She wasn't wrong that ResponseSync's core value depended on staying fast, and I wasn't wrong that speed and confidence, applied to source data that was occasionally simply incorrect, could produce an answer that was fast, confident, and entirely wrong all at once. The genuine difficulty was that neither of us, in that design review, had yet lived through the specific night that would finally force the two of us to weigh those competing truths against real consequences rather than hypothetical ones. The evening this story turns on was the second week of June, a freight train derailment on a rural line roughly 40 minutes outside the city, 3 tank cars off the tracks, one of them actively venting vapor from a damaged fitting, ResponseSync's dashboard identifying the car's placard as a moderately hazardous industrial solvent, calculating a recommended 200-yard evacuation radius and level C protective equipment, parameters my team began implementing within minutes of arriving on scene. I was doing my own visual assessment of the venting car from a safe distance, a habit I'd never once skipped across 20 years regardless of what any lookup system displayed, when I noticed the vapor cloud's color and behavior didn't match what ResponseSync's identified solvent should be producing, a distinctly yellowish tinge and a specific, acrid quality to how it hung low near the ground rather than dispersing upward the way the identified chemical's known vapor density should have behaved. Command, this is Bridget. I need everyone to hold current positions. I'm not confident the placard's chemical ID matches what I'm actually seeing coming off that car. The vapor's behaving wrong for what response sync says this should be. Systems showing high confidence on the placard match, Bridget, standard industrial solvent, level C should be adequate per the database. I know exactly what the system's showing, and I'm telling you what my own eyes are telling me right now standing closer to this release than anyone else on this scene. I've seen this exact vapor behavior once before in 20 years, and it wasn't from anything level C protective equipment was built to handle. I'm upgrading to level A gear and expanding our evacuation radius until we get independent confirmation of what's actually in that car. I want to describe what I actually did next, because it fell squarely within my formal authority as incident commander and, honestly, within the one rule every responder trained under me has followed since long before response sync existed, that a commander's direct sensory assessment of an active release overrides any lookup system's recommendation whenever the two genuinely diverge, full stop, regardless of how confident the system's identification appears. I ordered an immediate upgrade to level A protective equipment for my team and expanded our evacuation perimeter to 400 yards, well beyond response sync's recommended 200, a decision that pulled additional responders back from positions they'd already begun establishing and that added real logistical complexity to an already chaotic scene. I called for an independent field test kit, a portable chemical identification device our unit carried specifically for exactly this kind of discrepancy, and had my most experienced technician run a direct sample from the vapor plume itself rather than continuing to rely on the placard-based identification alone. The field test came back within 20 minutes, identifying a considerably more reactive and toxic industrial compound entirely different from what the car's placard and response sync's manifest lookup had confidently identified, a genuine placard mismatch, later traced back to a reloading error at the shipping terminal 3 days earlier. That would have left every responder on my team in level C equipment standing within an evacuation radius roughly half of what the actual chemical's safety data required. Those 20 minutes waiting on the field test carried their own particular weight, my team already repositioned in level A gear well back from the original perimeter, the derailed car still venting steadily under the floodlights we'd brought in as the evening light faded, and I found myself running the same mental checklist my mentor had drilled into me 2 decades earlier: trust the color, trust the behavior, trust the smell before you trust the label, a checklist that had carried me safely through exactly one other night like this one, years before response sync had ever existed to disagree with me. I stood at the command post with my field test technician, a steady, thorough man named Roosevelt who'd worked hazmat scenes alongside me for 9 years, both of us looking at the confirmed identification now sitting directly beside response sync's original, confidently wrong recommendation on the same tablet screen. Level C gear and a 200-yard radius for a compound that actually needed level A and 400 yards, Bridget. If you hadn't caught that vapor color, we'd have had responders exposed at exactly the distance the system told them was safe. I've been telling Nadia for a year that a fast, confident answer isn't the same thing as a correct one when the underlying placard data itself can be wrong, Roosevelt. I didn't have anything beyond 2 old incidents from my own career until tonight made the gap impossible to keep deferring. I photographed the field test results and the original placard alongside each other, logged the full incident report myself, and called Nadia directly rather than letting the report reach her secondhand through the normal chain. Nadia drove out to the scene herself within the hour, having heard enough over the phone to understand this wasn't a routine equipment question, and I want to describe the conversation honestly, because it wasn't simple vindication for either of us, even with a confirmed placard mismatch sitting in hard fact in front of both our eyes. A placard mismatch that would have left your entire team in level C gear within a radius the actual chemical needed doubled, Bridget. That's not a marginal miss, that's exactly the gap you've been describing to me for a year, sitting right here where I can finally see it myself instead of just hearing about 2 old incidents. I've been telling you the placard's only as reliable as whoever attached it at the shipping terminal, Nadia. I didn't have anything beyond my own career's history until tonight made the gap impossible to keep deferring. This wasn't the system malfunctioning, it was the system doing exactly what it was built to do, trust the data it was given, in the one scenario where that data itself was wrong at the source. Which is exactly the gap I need to sit with, and I know that now in a way I genuinely didn't let myself believe a year ago, when you first raised it in that design review. I wasn't dismissing you because I'd stopped trusting your judgment, Bridget, I built Response Sync because I spent 8 years in the field myself, watching responders lose critical minutes manually researching chemical data while a release kept spreading, and I genuinely believed instant, confident lookup solved that completely. I think I let myself believe fast and confident was the same thing as verified, right up until tonight showed me exactly the scenario where those two things came apart. I know that, Nadia. I'm not angry at you for wanting to save responders those critical minutes. I've worked scenes where slow manual lookups genuinely cost us time we couldn't afford to lose. I'm telling you that the one time it mattered, a confident 200-yard radius was asking my entire team to trust paperwork that a loading dock error 3 days earlier had quietly made wrong, and the only reason we're standing here talking about an incident report instead of exposed responders is that 20 years taught me never to fully trust a placard over what a release is actually doing in front of me. She was quiet for a long moment, looking at the damaged tank car still venting under floodlights in the distance, and I watched her run the same calculation I imagined she'd been running since the field test results reached her, the particular engineer's math of how many other incidents, across 2 years and however many placard lookups the system had processed, might have carried the same invisible source data gap without one commander's 20 years of reading a release directly happening to catch it in time. I keep thinking about the version of tonight where you'd been further from the venting car when you noticed the vapor color, or too busy managing perimeter logistics to do your own visual assessment at all, she said, finally, still watching the scene, or the version where you'd stopped raising this at family dinners after I pushed back a year ago, because I outranked the argument on paper even if I'd spent 8 years in the field myself before I ever built anything. I don't like sitting with how much of tonight came down to you personally deciding a habit like checking the release directly couldn't ever become optional, no matter how confident the system looked. I don't love sitting with that either, Nadia. A system this good shouldn't need one commander's stubborn 20-year habit as its last line of defense before a whole team ends up underprotected against a chemical the paperwork got wrong. That's not a compliment to me, it's a description of exactly the gap we both need to close. You built something genuinely good across 2 years, and I've never once told this agency otherwise, but genuinely good isn't the same as verified all the way down, and I think somewhere in that first year you let yourself believe fast and confident could stand in for a source you couldn't actually confirm. What Nadia and I built together over the following months, working with the agency's training division directly, was a standing mandatory field verification protocol requiring a portable chemical test kit confirmation before any incident commander could finalize protective equipment and evacuation parameters, alongside a prominent placard mismatch warning built directly into Response Sync's interface itself, closing the exact gap that had let 2 otherwise excellent years of instant, confident lookup quietly inherit the one failure mode that lived entirely outside what any database could verify on its own. I still trust my own senses over a dashboard reading at every scene I command, considerably less anxiously now that every responder in the state carries the same mandatory verification step rather than relying on one commander's personal 20-year habit to catch a mismatch the rest of the system had no way to see. Roosevelt still brings up that June derailment occasionally, over coffee back at the station, the particular field test neither of us has ever needed to explain twice to anyone who's since heard the full story. Nadia and I talk about Response Sync's ongoing refinement most Sundays now, at the same family dinner table she's been sitting at since she was 12 years old, except the conversation carries a specific new weight neither of us fully had before that June evening. She told me once that the hardest part of the whole episode wasn't building the verification protocol at all, it was sitting with how completely 2 clean years had let her trust a placard's declared chemical identity as reliably true, right up until her own stepmother's 20 years of reading a release directly finally made the gap impossible to keep deferring. A chemical doesn't lie about what it actually is, even when the paperwork does, and what I've learned, watching a system my own stepdaughter built get this one thing wrong for a year before finally getting it right, is that the most dangerous gap in a genuinely well-built system is often the one sitting quietly at the exact point where the system has to trust information it was simply handed, with no way of its own to verify that information against the physical reality it's actually describing. It took a wrong-colored vapor cloud, a 20-minute field test, and a stepmother and stepdaughter who trusted each other enough to argue honestly across a family dinner table a year before it mattered, to finally close a gap that 2 otherwise excellent years of engineering had never quite found their way to on their own.